last section of the Unit 3. And the last thing that we're going to talk about for functions and relations is this arithmetic sequence. So you see a lot of this on the SAT and PSAT, trying to set us up to find a formula to find the next number in the sequence. So what is an arithmetic sequence? It is a sequence in which the difference between any two consecutive numbers is constant. And I'm going to say it doesn't even have to be numbers, it can be terms too, because sometimes we'll see a variable thrown in there. So here's what I want you to take out of this definition. Okay, it's a sequence in which the difference between terms, any consecutive terms, is constant. So what does this word consecutive mean? Remember, it means one right after the other. So we've already done that in Unit 2, and so now we're looking for the arithmetic sequence. So what is the common difference? The common difference is the numerical difference using the letter D between any two consecutive terms. And so it is understood in algebra to note a lowercase d, and that stands for the common difference. So let's look at identifying an arithmetic sequence. So it says determine whether the arithmetic sequence is, or determine if the sequence is arithmetic. If yes, identify the common difference. So remember, it's consecutive, so I go from 1, 5, 9, 13. Do I notice a pattern here? Am I adding 4 consistently? Yes. So it is an arithmetic sequence, and the difference is positive 4. So I just note 4 there. Look at number 2. 1, 3, 5, 8. I'm going up by 2, up by 2, and up by 3. So is that an arithmetic sequence? No, because my pattern doesn't remain the same. It's 2, 2, and then 3. Look at number 3. 8, 6, 4, 2. So down by 2, down by 2, down by 2. Yes, and the difference is negative 2. So see if you can do 4, 5, and 6 on your own, and let's see if we get it. So surely you're back from pause. And the difference, and notice I'm putting D equals negative 3. Here it is no, because I'm multiplying by 2. So even though it looks consecutive, I can see a pattern, but it's multiplication, not addition. So it's not arithmetic. It's multiplying by 2. And so this one is yes, and the difference equals negative 1. All right. So now on number 7 through 8, it says, given the arithmetic sequence, find the next 3 terms. So now I need to know, what is my pattern here? It's up by 4, 4, and 4. So 25, 29, 33. My pattern, my D is equal to 4. And number 8, once you notice the pattern, is going from negative 3, negative 3, negative 3. So it's negative 7, negative 10, and negative 13, and my common difference is negative 3. On this one, I go, I'm adding 6, I'm adding 6, I'm adding 6, so 16, 22, 28, and my common difference is positive 6. So that's what it means when we continue the arithmetic sequence. Now, when we get into some numbers and we're asking to find a certain number in the term, it's going to get really hard and tricky. So if I, just threw this up there and asked you, what is the 5th term in the sequence, or the, here it's easy to see the 5th term. But what if I asked you, what would the number be in the 111th term? Well, I don't want to do this 111 times. So there needs to be an easier way, and there is an easier way. And so in math, they found a pattern, and from that pattern, we find a formula. So a formula that we can use to make it simple. where I don't have to go through 100 million times to figure out what that number is in the next term. So here it is. When you find the arithmetic sequence formula, you are looking for the nth term. And the nth term means if I asked you what is the 95th term, it could be what is the 1,000,002 term, it could be 1,017, what is that term of an arithmetic sequence, and we use it by looking at this formula. So there's a certain formula. We already know that D stands for the common difference. We've already talked about that above. So that's the common difference. A sub 1, this means the first number in the sequence. What is the very first number in the sequence? Okay, so that's some of the variables that you need to know. So here is what it looks like. AN, now this N stands for if I'm asking you the number in the sequence that we're looking for. So if I asked you the 54th term, that's what AN would be. It would be 54 because that's the number in the term that we're looking for. And then it's the common difference times N minus 1 plus A sub 1. Okay? So D stands for the common difference, and A1 is my first term. So let's take a look about what that is going to allow me to do. So we're kind of looking for this N, and I'll tell you more about that in a second. So using the formula, it says find the 19th. So now I'm looking for the 19th term, right? So what I'm going to do here is first I'm going to find out, okay, 1, is it an arithmetic sequence? So I look, how do I get from 7 to 13? I add 6, add 6, add 6. So it's consistent. It is an arithmetic sequence. So I know that the D is 6. And I know that the first term is equal to 7. So now I'm going to use this formula. Now remember, I'm looking to find the 19th number in the pattern, right? So the formula that helps me find it is going to be 6 times n minus 1 plus 7. Now I distribute 6n minus 6 plus 7, and I get 6n plus 1. Okay? Here is what I need students to understand. This right here is my overall formula. So when you're looking on homework, you need to, number 1, find me the formula. And this is the formula. I'm asking for 2 things on homework. I'm asking for the formula, and I'm asking you to find the 19th term or whatever term in the sequence. But this is the first part I'm looking for. So now, when I'm looking for the 19th term, I'm going to plug in 19 for n. So I do 6 times 19 plus 1. And I get 4 and 114 plus 1. I think that's right. And I get 115. So if I continue this 19 times, 115 would be my answer. Students all the time ask, well, why do I need a formula if I can just find 115? I can plug in 19 way up here, and then I just only have to do everything once. Because I need this formula. Because what if I asked you 7 different numbers? What if I wanted the 19th term? What if I wanted the 54th term? What if I wanted the 1,000,002 term? What if I wanted, what if we went backwards in the term? What would that term be? This is so important because that is my rule. Remember, functions are rules. We are establishing a rule. So 1, I need the rule, the formula, and then I need the number in the sequence, okay? So I want you to do a couple of these. Let's do some even ones on the back side. So we'll do 12 and 14. So you can pause it and then just jump back in and see if we're getting the same thing. What I do want you to do is write down the formula every time. So a to the n equals common difference n minus 1 plus a1. That's the formula that I use over time. Now remember, the instructions say find the 19th term. So I'm going to put a sub 19 over here just to remember what was written up above. But I also want the formula, I want the rule, and I want the number. Okay, so 2 things I'm looking for, rule and the number. So here we go. Is it an arithmetic sequence? It is because we're adding 3 consecutively. So I know that my D equals 3, and the first term in my pattern is negative 11. So here I have D equals 3, n minus 1 minus 11. When I distribute, I get 3n minus 3 minus 11. So 3n minus 14. That's my rule. This is my rule. Now that I have my rule, I'm going to plug in 19. 3 times 19 minus 14, and 3 times 19 is 57. 57 minus 14 is going to give me 43. So 43 would be the 19th term in that sequence. Okay? No, it's not. It's 40. Yeah, 43. That's correct. Okay. I'm going to expand my screen a little bit. All right, so let's see how we do. So I'm going to write my formula. Remember, my formula is common difference n minus 1 plus a1. Is it an arithmetic sequence? I'm subtracting 5, subtracting 5, subtracting 5, so it is. So negative 5, and then the first term in my pattern is negative 16. So when I plug it in, I get negative 5 times n minus 1 minus 16. I distribute my negative 5. And then when I combine like terms, this is the rule that I'm getting, negative 5n minus 11. So to find the 19th term, I plug in 19, and then I get negative 200. 5 times 20 is 100. 100 minus 5 is 95. Golly, that took me forever. Negative 95 minus 11, and that is going to give me negative 106. So 106, negative 106 would be the 19th term, and then my rule is negative 5n minus 11. All right, so let's look and find out when would we use these in applications. So in applications, let's say we visit the Grand Canyon, which you will be doing because you're in 8th grade. So you're going to visit the Grand Canyon and drop a penny off the edge of the cliff. Do not do this. You will get in trouble. It is literally a felony because the rate at which it falls, it can knock somebody in the head and they can fall. Don't do that. They will tell you that time and time again. So anyway, the distance the penny will fall is 16 feet for the first second, 48 feet the next second, 80 feet the third second, and so on. Write a formula to represent this sequence. So I'm looking for my formula. So let's look at the pattern here. Remember, my formula says an equals d times n minus 1 plus a1. So common difference. So the first second is 16 feet. The second is 48, then 80, and then so on. So what is my common difference here? 16 and 48, my common difference is 32. And is that consecutive? 32 to here, it's 80. So my common difference is 32. And the first number in my sequence is 16. So I've identified A1 and I've identified difference. So when I plug it in, I get 32 times n minus 1 plus 16. So 32n minus 32 plus 16 is 32n minus 16. That is my formula. That is my rule, 3n minus 16, 32n, what am I doing, 32n minus 16. So that is my rule. Let me rewrite it over here, 32n minus 16. So how far will the penny have traveled after 6 seconds? So now I'm looking for the 6th term in my sequence. So I'm just going to plug in a 6 here. 32 times 6 minus 16, and when I do that, I'm going to get 176. And remember what that stands for up here. It stands for feet. So after 6 seconds, the penny will fall 176 feet. So that's kind of cool how that works in certain applications if you know that you have an arithmetic sequence. Let's look at a different arithmetic sequence. Money, bank, all the time we use it. The total bank loan for Sarah's new car is $15,265. The bank automatically withdraws $295.80 each month to pay off the car. Write a formula to represent this sequence. Perfect. So my starting point, the first term is $15,265. That's my A1. That's the first part, okay? Now, they automatically withdraw $295.80. So they're telling me every month that common difference is $295.80, but it's negative because they're withdrawing. So I have my common difference, I have my A1. The formula, remember, is D times N minus 1 plus A1. So the common difference is negative 295.8 n minus 1 plus 15,265. So I've simply plugged in D, plugged in A, and now I'm going to distribute and simplify. And when I distribute, I get negative 295.8 n plus 295.8 plus 15,265. So I get my formula is negative 295.8 n, and when I add these together, I get plus, I'm cheating here by looking, 15,625. So that is my formula. So now, after 2 years, what's it going to be? Well, first, it's asking 2 years. What is my common difference? They are taking this out per month. So N stands for months. So I need to find out 2 years. So I'm not going to plug in 2 for N. I'm going to plug in 24 because that is months. So I use my formula, negative 295.8, 24 months plus 15,625. And when I do my math, I get $8,165.80. So the balance after 2 years is $8,165.80. Okay, so that's how you would use arithmetic sequence to solve problems, which we will be doing. If you have questions, come and see me. Good luck.